Kita Bahiyah dan simak ini.
Hi, my name is Nur Anissa Shazana binti Saiful Nizam.
Hi, my name is Lily Patricia.
And my name is Saratun Nazah Akira binti Majari. In this video, I will present our topic titled Hazard Identification and Control Measure in the Rubber Manufacturing Industry. Our presentation will cover 5 main parts, which is Introduction to the Industrial Process, Hazard Identification, Risk Assessment, Control Measure based on the Hierarchy of Control, Conclusion and Recommendation. So firstly, let's begin with the introduction. The rubber manufacturing industry involves so many steps such as mixing raw materials, rolling or extruding, vulcanizing, cutting, and cleaning process. This process exposes workers to different types of hazards including chemical exposure, heat, dust, machine-related injuries, ergonomic strain, and even biological risk from contaminated waste. According to past research, workers are exposed not only through inhalation of dust and fumes, but also through skin contact with harmful chemicals such as polycyclic aromatic hydrocarbons, which known as IHS and nitrosamines. This substance can cause dermatitis, and for the long-term causes, it can increase the risk of cancers. Because of this, hazard identification and effective control measures are very important to protect workers and reduce occupational disease. Next, I will pass to the second presenter to discuss the hazard identified in the rubber manufacturing process.
My name is Siti Nurbaya. So now I present the hazard identification and risk assessment for the rubber manufacturing process. The purpose of this hazard identification is to recognize and evaluate any situation that may cause injuries, illness, or property damage.
First is handling and mixing raw materials. This activity involves a chemical hazard where workers are exposed to dust and chemical fumes. The associated risks include breathing difficulties, skin irritation, and potential long-term disease such as lung or bladder cancer. The likelihood shows is 4, meaning the incident is likely happen, and the severity is 4, indicate to a major injury resulting a high risk score of 16. Second is the rolling or extruding process. This process presents a physical hazard involving moving machine parts and hot surface. The risks include burns and possibly entanglement with the machinery. This process has a likelihood of 4, which is likely happen, and a severity of 4, which can cause major injury, and also it's producing a high risk score of 16. The third one is the vulcanizing or curing process. This stage involves both physical and chemical hazards, including exposure to heat, fumes, and vapor. The risks may include burns, respiratory issues, and long-term illness such as cancer. This process likewise carries a likelihood of 4, which is a likely happen, and a severity of 4 that can cause major injuries, and giving another high risk rating of 16. Fourth is cutting rubber with metal wires. This presents a physical hazard due to short metal wires and uncured rubber. The risks include cuts, skin infection, and possible long-term health issues. The likelihood is 4, which is likely happen, but the severity is 2, that can moderate injury resulting in a medium risk score of 8. Next is working continuously with fumes or high temperatures. This situation exposes workers to a psychosocial hazard involving long working hours under hot and stressful conditions. The risks include physical fatigue, stress, and reduced concentration. That shows a likelihood of 5 that almost certain happen, and a severity of 1 that can cause minor injury, and shows the producing a medium risk scores of 5. Next is lifting heavy rubber rolls or materials. This activity introduces an ergonomic hazard due to heavy lifting and awkward posture. The risks include back pain, muscle fatigue, and long-term muscular problem. The likelihood is 5 that can almost certain happen, while the severity is 2 that can moderate injuries, giving a medium risk score of 12. Lastly, cleaning or handling rubber waste. This involves a biological hazard where the rubber waste may contain mold or bacteria. The risk includes allergy reaction, rashes, or skin infections. The likelihood shown is 4, which is likely happen, and the severity is 2 that can moderate injury, and giving a medium risk score of 8.
Okay, so for this slide, I will explain the high-risk hazards involved in handling and mixing raw materials, as well as the rolling and extruding process. This stage involves direct exposure to chemicals and machinery. So proper control measures are very important. So I will go through the control one by one. So first, for handling and mixing raw. For the handling and mixing of raw materials, the first control measure is elimination or substitutions. This includes using safer or less toxic chemicals to reduce workers' exposure. We also use pre-mixed or sealed containers so that the materials are handled less frequently, which lowers the risk of contacts. Next, engineering controls involve installing local exhaust ventilations to remove harmful fumes and dust from the work area. So proper chemical storage and clear labeling are also done to make sure workers can identify materials safely. Next, for administrative controls, workers are given proper chemical handling training so they understand the right procedures. Regular air monitoring is also carried out to ensure the workplace remains safe from chemical exposure. And lastly, for PPE, workers must wear gloves, respirators, and chemical-resistant clothing. Safety goggles or face shields are also required to protect the eyes from splash or fumes. Next, for rolling and extruding process. So first, for the rolling and extruding process, elimination or substitutions means using automate or semi-automate system. This help reduce direct work contact with moving parts and lower the chance of accidents. Next, engineering controls. Engineering controls include installing machine guard and emergency stop buttons to prevent injuries. So, adequate ventilation is also provided to reduce heat and fumes in the area. For administrative controls, workers receive training on how to operate the machine safely, so regular inspections and maintenance are also carried out to ensure the equipment stay in good conditions. And lastly, in terms of PPE, workers should wear heat-resistant gloves and protective clothing because the machines are hot. So safety shoes and face shields are also required to prevent injuries. So moving on to the medium risk hazards, which is this slide is focused on cutting uncured rubber and lifting heavy rubber rolls. So I will explain the safety control used for both activities. Okay, so first is cutting uncured rubber. So for elimination and substitutions, to reduce risk during cutting, safer methods such as use pre-cut materials are applied. So sharp metal wires are also replaced with safer cutter tools to prevent accidentally injuries. So for engineering controls, tools must be maintained properly to ensure the function safely. So good lighting is also provided so workers can see clearly while cutting. Next, for administrative controls, workers receive training on the proper cutting technique. So a nearby first aid kit is also prepared to ensure quick action in case of minor injuries. So lastly, for PPE includes cut-resistant gloves and protective clothing to prevent cuts. So safety goggles or face shields are used to protect the eyes from flying particles. Next, lifting heavy rubber rolls. For elimination and substitutions, to reduce manual lifting, forklift, hoists, or trolleys are used. This helps minimize physical strain on workers. Next, for engineering controls, workstations are designed ergonomically and heavy items are stored at waist level to avoid unnecessary bending or overreaching. And next, for administrative controls is include providing lifting technique training and rotating tasks to reduce worker fatigue. And lastly, for PPE, workers should wear safety shoes and a back support belt to protect their spine and reduce the risk of back injuries.
Based on our review and the case presented, occupational exposure in the rubber manufacturing industry remains a significant health concern. Workers are exposed to harmful chemicals through inhalation and direct skin contact, especially when handling uncured rubber. The case of the worker with a rubber tattoo shows an under-recognized exposure route where repeated skin impactation can occur during daily tasks. Although current evidence does not yet prove that thermal exposure directly causes skin cancer, exposure to PAH, nitrosamines, and benzene is strongly linked to bladder, lung, stomach, and blood cancers. When skin exposure is combined with inhalation exposure, it increases the overall toxic burden on workers. Therefore, preventing occupational diseases in this industry requires multiple strategies, including engineering control, proper PPE, worker education, and ongoing health monitoring. We also highlight the need for long-term research to better understand the carcinogenic risk of thermal exposure. In conclusion, despite technological improvement, stronger preventive measures and safer chemical alternatives are still necessary to protect workers in the global rubber manufacturing industry. Based on our findings, we propose several recommendations to improve workplace safety. First, engineering controls should be strengthened. This includes enclosing high-emission processes, installing effective local house ventilation, and replacing hazardous chemicals with safer alternatives. Second, personal protective equipment must be improved. Workers need ergonomic, chemical-resistant gloves and protective clothing, and PPE use must be consistently enforced. Third, administrative and educational measures should be enhanced. This includes regular training on chemical hazard, promoting good hygiene practices, rotating workers to reduce prolonged exposure, and conducting frequent workplace inspection.